My name is Harvendra Singh, and I'm the Vice Chair of Florida West Coast Computer Society, and I have with me my chair as well on the IEEE Computer Society Antra. So thank you everyone for joining. I have around 20 years of software development experience, which spans software development, cloud technologies, AI, machine learning, uh, and pretty much all the phase of the software development lifecycle. So in today's session, we are gonna this is a panel discussion from cloud native to AI native, building AI-driven architecture with integrated cybersecurity. And I would request all the panelists. Our panelists are Amit Prasad, one of the panelists, Navneet Tyagi, Abhik Sengupta, and Vishi Bhatia. So I will request all the panelists to introduce themselves.
Yeah, let me go first. My name is Amit Prasad. I have around 20 years of experience in the IT side, and I am also a senior member in the IEEE, and I'm also having a YP chair in Louisville section. And I'm currently working on all these technologies like cloud, AI, and Microsoft technologies, right? So that's all from my side. I'm passing to my other panelists.
Yeah, hey, hello everyone. My name is Abhik Sengupta. I work as a principal architect in IBM. I have around 19 years of experience, and I'm also working in data and AI sector, and been doing a lot of cloud native and AI things for past a decade or so. So I'll pass it on to the next panelist.
Hey everyone, this is Navneet, and I have more than 19 years of experience, currently working as senior engineer at Finance of America, and I work in cloud technologies and AI, AI native systems, and software development, and I'm also senior IEEE member from Houston section. Thank you.
I guess I'm only left. So, hi everyone. This is Vishi Bhatia. I have now close to 18 years of experience in the IT. I have masters in information technology, and my main focus of domains have been healthcare and pharmacy. Currently, I work for Tata Consultancy Services Limited in Louisville, Kentucky, and in the healthcare unit, and we have been supporting various Fortune 500 companies in their digital transformation journeys. From last few years, our focus has been, towards digital transformation and legacy modernizations, focusing on AI and cloud. Um, I am the Louisville YP Vice Chair, and I'm associated with. I'm also IEEE senior member, associated with other organizations as well, like ACM, AAAI, project management professionals. So yeah, happy to be here, and also want to thank Harvendra and Antra for setting this up. Thank you.
Thank you, everyone. So now let's get us started with the panel. So now we have every panelist has been introduced themselves. So today's topic is from cloud native to AI native and building AI-driven architecture with integrated cybersecurity. I will be asking questions, and also I will be participating as in when needed. So we will be asking a couple of questions to the panelists, and then followed by the Q&A session. So we will leave some time for Q&A to the audience. Okay, so let's go with the first question. So first question I have is, how is the shift from cloud native to AI native changing the way we design systems and architectures? So I would say, Amit, would you like to take this question? Please unmute yourself, Amit.
Sorry, I'm not muted. I'm talking in English. Sorry, very sorry. So thanks, Arvind, for asking me this thing. I think it's a very good question, right? It's a very demanding things, right? So basically, the shift from cloud native to AI is changing system design in subtle but fundamentally way. Right. Cloud native architecture focused on scalability, resilience, and effective resource using. Right. Breaking applications into microservices, automatic deployment like using a CI/CD pipeline, designing right. So those principles still matter, but AI native system introduce a new layer of complexity. I think everyone agreed on this point. Systems are no longer just deterministic; they learn, adapt, and sometimes behave unpredictably. Right. There are so many examples available. Just like we are working in the healthcare domain, so we are facing because we also having challenges to implement AI, right? But we are trying. So in native AI native architectures, the logic of the system is no longer fully defined in code. It is partially embedded in model trained on data. This means design decision must now account for data quality, model behavior, and continuous learning. Right. Instead of managing services, team must manage model life cycles, versioning, and evolutions. Right. API return probabilities rather than exact answers. Right. That is the core problem right now. I'm saying that, like, which changes how downstream systems handle responses, errors, and user expectations. Right. So what are the observability here is it's no longer enough to track CPU, memory, and latency. You also need visibility into model performance, drift, and interference quality. And in all of these, security shift is also there with new concerns like prompt injections, data leaking, misuse of AI outputs. Right. Ultimately, the AI design pushes architect to think beyond infrastructure. Earlier, what we think, we just think about the infrastructure and we start designing the application according to the available infrastructure. But now we need to think as an architect, I need to think about beyond that. We need to think about all these pieces, how going to fit into the system towards system that combines software, data, and intelligence. It requires tighter collaboration between developer, data scientists, and operation teams. So as people are saying, we are going to lose job because of AI. So these are jobs are shifting. So basically, people need to reskill ourselves, right? The result is powerful system, but once demand greater discipline, governance, and thorough design to ensure remain reliable, secure, and trustworthy. I think these are all
Yeah,
the main 4 points.
yeah,
Yeah,
very
yeah,
good.
great point. Yeah, Harun, if you don't mind, I just want to add, great
Sure.
point, Amit, but just wanted to add, when you touched about healthcare, right? As I said that I'm from the healthcare background, right? From the past few years, we have been trying to see everybody trying to reach the, run off, get on the AI bandwagon. So we have been trying what we can do from the AI, from the healthcare industry. And you brought a good point, how the shift is happening. But as you know, right, the in healthcare industries, right, the shift is very, very pronounced. I'll tell you why. Uh, Currently, the systems that we have built right now are very rule-based engine. They are hard-coded in the legacy applications and they are very rule-based. Whenever whenever an enhancement or development opportunity comes, we have to go and alter the rules-based adjudication, work on the rule-based adjudication. But now what the focus in is what I have seen in my industry, right? The focus is they want us to go away from the AI rule-based engine, which was also cloud native, and go to AI assisted decision making. So the system, they still want the accuracy of rule based engine, right? But they want the AI assisted AI native designs to to do to still have that accuracy, compliance, and learn and in fact improve how we process the claims today. Specifically, I'm talking about healthcare claims. So the good on your point, but yeah, I think in healthcare industry the shift is very pronounced.
Yeah, yeah, definitely. Yeah, thank you, Amit and Vishi. So I will go with the next question. What are the architectural patterns are emerging as the best practices for AI native systems? So, Abhik, if you like to go through?
Sure, absolutely.
Yeah.
So thank you, Harvinder. What we are seeing is that AI native architectures are not replacing cloud native systems, but they're evolving from it. But they introduce fundamentally something different paradigm, systems that are probabilistic, data driven, and continuously learning. There are few emerging patterns that we can note down here. First is hybrid AI plus deterministic architecture. Organizations that are not relying on AI alone, they are combining AI-driven insights with rule-based systems to ensure reliability, auditability, and control. This is especially critical in regulated industries. The second pattern could be the RAG pattern. This is becoming very foundational. Instead of training models on everything, we ground them in the enterprise data at runtime. That improves the accuracy, reduces the hallucinations, and most importantly, it gives better control from a security and data governance standpoint. The third pattern is we are seeing that the rise of AI, the agent-based architectures. These systems can reason, act, and iterate. But while they unlock automation, they can also introduce some new risks. For example, some privilege escalation or unintended actions. So security has to be very tight and embedded at the agent level. Another important pattern is the AI gateway that control and control plane. Think of it as an AI gateway, but for AI. API gateway, so like it centralizes the model access, enforces policies, manages routing, and provides observability. This is becoming critical to prevent uncontrolled AI usage across enterprise. And finally, what all of these are tying together is using the LLM ops or ML ops with security built in it. Many of them call as ML sec ops as well. This ensures models are versioned, monitored, validated, and continuously governed across their life cycles. So the big shift is that the AI native systems are becoming composable, governed, and security aware by design.
Yeah, that definitely. So I would like to, those are really good points, Avik. And however, I also want to add few things here. Like AI native systems are increasingly built around an orchestrator layer, and that sits in the request path and routes work to models, tools, and services based on intent and context. This is a shift from static microservices calls to system that can region, choose tools, and adapt at runtime. So a practical set of best practice patterns looks like this apart from the points you covered. So like agent based decomposition instead of only one splitting functionality into services, organization split work across specialized agents that coordinates on a task. And then another could be the another one is feedback loop architecture, human review outcomes, um, and then the outcome tracking, and also prompt model updates and treats as core system components, not afterwards. And then also policy as a and guardrail layers, right? Security, access control, and content filtering are inserted around model calls so the AI can act safely and in production environments. So now moving to the next question.
So before
Yeah.
that, sorry, Harvinder. Since we are talking about the architectures that are emerging from the AI native, I just got a thought from in my head that at what point of time does incremental AI adoption fail, requiring a full architectural redesign?
Oh yeah, that's a very good question, Abhik. So the incremental AI adoption works well at the early stages, especially when organizations are experimenting or adding AI to improve specific features like recommendation, forecasting or automation. In this phase, AI is more an enhancement than the core capability. However, this approach starts to break down when AI becomes central to how the business operates. So one clear signal is the need for real-time decision making. If your system are still designed for batch processing or delayed responses, they won't support use cases like fraud detection, dynamic pricing, or real-time personalization. And then another challenge is data fragmentation. When data is spread across multiple systems without a unified pipeline, it becomes difficult to train, deploy, and maintain models effectively.
Yeah, that's a very good point, Harvindra. One point, so I want to add a couple of points from my side.
Sure.
In my experience, scalability is also one of the major factors. And because what works for one AI use case often doesn't scale across multiple teams sometimes, or even for business function as well. So I would say at this stage, teams spend more time managing pipelines and fixing inconsistencies than delivering values. That's when incremental changes are no longer enough, and organization need to rethink their architecture around continuous data flow, real-time processing, and integrated AI pipeline as well. So the shift would be from adding AI to existing systems to designing systems where the AI is a core part of the architecture as well.
Yep. Thank you,
Yeah,
Navneet. Yeah, that's a
thank you.
very good addition.
Excellent points, actually. Thank you.
Yeah. So let's move to our next question. How can cybersecurity be embedded into AI architecture from the beginning rather than added later? I would go with Navneet. Navneet, would you like to answer this
Yeah,
question?
definitely. That's a great question, Harvinder. It's a very relevant one because everyone is talking about AI native and how we can also integrate cybersecurity even at the beginning rather than at the later stage. Because it's when we add it, we try to add it at the later stage, it's too late and it will require a lot of changes. So, what I would suggest is embedding cybersecurity in AI architecture from the beginning itself, which is often called secure by design AI, which is essential because AI systems introduce unique risks that cannot be effectively mitigated later on. And the process starts with AI specific threat modeling, which will be identifying risks such as data poisoning, model inversion, adversarial inputs, and prompt injection. So these are different kind of threats, uh, and which will be like shifting the focus from just securing infrastructure to also protecting data as well as the models as primary attack surfaces. Next, I would say organization must secure the entire data lifecycle itself, so which includes the validating the data sources, tracking data lineage, enforcing strict access controls, including techniques like differential privacy, integrity checks to prevent tampering, and even at the model level, defenses such as adversarial training, output filtering, and confidence threshold helps ensure robustness and reduce misuse. So that is the entire data lifecycle which needs to be protected. And next, I would say, which is equally important, is securing the supply chain AI as well. The models, datasets, dependencies should be verified, signed, and deployed through secure CI/CD pipelines to prevent compromise. Security must also be embedded directly into the system architecture using the zero trust policy. We don't have to we have to, even if we have to do it like each and every point, we have to use the zero trust policy to make it secure, and we have to add isolation boundaries and stricter API controls.
Yeah. Thank you, Navneet. Anyone would like to add more to it? Yeah. So I would say that yeah, the continuous monitoring is also very critical with AI specific signals like input drift and abnormally query patterns. And finally, organizations should include human oversight, adversarial testing, governance policies, and fail-safe mechanism to ensure resilience and limit damage if systems are compromised. So
Yeah, that's a valid point. Yeah,
yep.
thank you.
So moving to the next question. So what does success look like for organizations adopting AI native architecture in next 3 to 5 years? And I will pick Vishi for this question.
Oh, okay. You said how the success will look like in the organization in the next 3 to 5 years, right? Okay, so
Yeah, the adopting AI native architecture in next 3 to 5 years. Yes.
okay, so let me tell you from the healthcare perspective. Okay, currently what we are doing right now using AI is like an add-on services, right? Trying to use for this functionality, or trying to resolve uh, uh, some business use case, right? But what I have seen from my personal experience, that right, success, what they are trying to do is like AI gets embedded into their core business workflows, right? As I said, not just isolated business functions, so in healthcare, this would usually translate into AI being part of the business functions such as claim adjudication. So claim adjudication is the system which adjudicates the healthcare claims. So something like clinical services, like prior authorization, fraud detection. So they want the AI gets embedded into the core business workflows, just not the add-on. They want it to be a decision-making layer, right? So to give you a very good example, currently a lot of these healthcare claims, right? Whenever the health claim processes, right, around 80 to 90% of these claims are auto adjudicated, meaning no manual intervention, right? But a lot of the other, like 10 to 20% of these claims, right, they need manual intervention, and this is a big operating cost, which in the healthcare industry, like especially if I tell you from my experience, right, which we are trying to see if we can utilize AI to minimize it. I'm sure we cannot make it zero. Some manual intervention will always be there, but how can we have AI embedded in the system? And if you talk about 3 5 years, definitely in 3 to 5 years, they want to get the AI system embedded into core business, functions. Like, and what outcomes they would see. What outcome would define success? Like reduce claim processing time. Obviously, if there's no manual adjudication, the claim processing time will reduce. Second benefit is, if you do that, obviously your administrative cost will reduce, right? Then they want AI. Obviously, when you are writing manual rules, engines are there, people are doing, manual decision making is there. There are very high chances of, human error that they are trying to reduce it through AI, and lastly, fraud detection. I should not lastly, but this is one point I want to add. Another member and provider experience. The more good accurate your claim is, the more success you give. It will improve the provider experience. And uh, there is other aspect that I want to touch here is, the healthcare industry is is a very compliant industry. You might have heard about HIPAA and CMS. They are very compliant. So you want to have a AI embedded systems, but you also want to have it a very trustworthy and governed AI. Meaning, you cannot in a healthcare industry, what I say, we are okay to overpay but not underpay. We don't want AI to be not be accurate. So especially in a regulated industry, so AI native systems must be HIPAA and CMS and other, or state Medicare, Medicaid, state compliant. Okay. uh, AI decision should be there, approving a claim or flagging it, abnormally, but it should be transparent, and we should be able to provide a reasoning of why our AI did this, you know. So these are things there, and the last thing that want to touch about is the real time claim adjudication, real time functions that we have today. A lot of times these claims are processed on in batch, meaning we get the claims in bulk and then we process it, and it takes few days to do it. A lot of providers are looking if for ways for doing their real time processing, and here we are also trying to utilize AI and trying to see, if that decision making could be real AI. We are not been there, we are not there yet, but we're trying to go there. So as I said, success will look like that AI is, I just want to conclude that success, I said a lot, but just want to conclude, that AI, it should be embedded in a way that it could be, it's firstly accurate, it could be governed, it's measurable, plus it's just embedded into our core business, not just standalone or doing small function here and there. So yeah, and providing better, results and outcomes for improving experience for patients and providers and members and everybody involved, from a healthcare perspective, I'm talking everybody involved here, but in other businesses as well, basically improving the customer experience.
Yeah, thank you, Vishi. Any other panelists would like to add something here?
Yeah, I just want to add, first I want to say, Vishi, you covered it very good from the healthcare standpoint. I would like to add a couple of points from the technology standpoint, right? Success also, from the technology standpoint, success would mean creating a ecosystem where AI behaves like a living system rather than a one-time deployment. So similar to how modern software relies on CI/CD pipelines, or AI native organizations adopt MLOps to continuously train and deploy and monitor and improve the models. Exactly something like that. It should be a a living systems, living and breathing system, and they should be anchored in a scalable cloud native foundation, leveraging containers, Kubernetes, and distributed data platforms like Databricks or Spark to ensure models can handle large scale and real time workloads effectively.
Yeah, good point, Abhik. Good point. I mean, we are right now focusing on our, as I said, I worked on legacy modernization. I've been working on legacy modernization, right? We are working on containerization because that's a first step that we want to, for the AI native architecture, right? That is one of the backbones that that we have, right? So we are trying to leverage containers, Kubernetes, Dockers, and trying to create data platforms like Databricks and Snowflakes. So yeah, that's a very good point that you brought.
And I want to
Yeah,
add
thank
here
you both.
one more point, Bhavin. Actually, we are talking about all the architecture design patterns, all those things. So I think I want to touch on the security as well, because security compliance is also equally important in the cloud or AI world, right? So I think we need to talk about on the security aspects also always, right? When we touch on the AI models, right, or we can say that we are going to host our application in cloud, right? So from the security perspective, we are going to take care of the PHI thing. If I'm talking about the healthcare, and if we are talking about the financials, right, we need to take care about the GDPR, right? So these are the security concerns, right? Every industry have their own compliance, right? Every domain have own compliance, and we need to regularize and govern the compliance, right? And always need to verify the security things. There are so many security vulnerabilities happens nowadays, and going forward, it's going to increase day by day, right? So it's going to be very vulnerable for the future softwares as well. So that aspect we need to be upfront or take care when we talk about the AI native systems.
Agreed. Yeah. Thank you all. So now let's go with the next question. But yeah, these are very good points and very good discussion. So are most organizations realistically ready to adopt AI native architectures today? Why or why not? Avik, I would like to, Amit, I would like to go
Okay,
to you
I'm
for this
taking
question.
this, no problem.
Yeah. Yeah.
So, as I said, many companies have solid progress in cloud native adoptions, right? But AI native architecture introduces a different kind of challenge, right? It's not just about deploying models, it's about managing data quality, model read lifecycle, governance, continuous evolution, and on top of that, security, right? These are the areas where many organizations are still struggling or still maturing ourselves, right? Without reliable data pipelines or clear ownership of model, AI system can quickly become inconsistent or hard to trust. Because if suppose if your team or suppose my team ask my enterprise team that I need this model, do you help me to provide that model? So they're not going to to do that, right? They're going to ask me a question, why you need that? Why are you not going to use in-house models for your applications? Why you need a specific model that is not available or approved within the organization, right? Or enterprise? Why you want to go? So you need to ready with all such questions answers, right? Because when organization going to adopt any models or anything like they're going to thorough review, they have a board, right? They're going to review the security compliance, they're going to review how they can utilize this, what are the constraint, all those things are a factor. So another factor in organization readiness is AI native system require closer collaboration between developers, scientists, and operation teams. In reality, these groups often work in silos, but bridging that gaps take time. And it's a cultural change as well. New process like MLOps, which means teams are still learning to implement effectively, right? Free developers or don't know about how to implement ML, right? So they need to learn the new things. There are also concerns around security that I already talked about, right? And the risk. Leaders are cautious about adapting AI in critical systems, like we talk about where we have a member data or any provider information, right? Or any of the compliance data that you need to be care about, right? So issues going to happen like hallucination or unpredictable outputs, right? This shows down large school adoption even when the technology is available. So the organization does not need to be fully ready to start, but many are successful adopting AI incrementally, adding AI features. Like in my organization, they are slowly moving towards the AI. They have first created the agentic AI and asked the team or enterprise to use that agentic AI, and they hosted the model within the intranet. They are not moving the things into internet. So that is the the, the security wise they have hosted, and they hosted the model in a single container. So if any vulnerability happen, that happen only on that container. It's not going to impact the whole server, right? So that's the things we are taking care while adopting the AI. So this phased approach allows team to build confidence, develop governance practice, and learn what works. So while most organizations are not fully AI native today, they are actively moving in that direction. The key is not the transformation, but building the right foundation data, processes, and collaboration to support it. Yeah, that's all.
Yeah,
On
thank
my
you,
Yeah,
Amit.
point.
Anyone?
yeah, yeah. Yeah, Harvin, if you don't mind, just give me a minute. I'll
Sure.
just
Yeah.
add something. Yeah,
Yeah.
yeah. I think as Amit put it out right, the organizations are not fully AI native right now. Obviously, everybody started doing the AI, utilizing in the last few years, right? But the difficulties that they have, right? I just want to point it out the difficulties that they have, right? Especially for the organization which are very legacy heavy. A lot of these applications, their platforms are built in legacy platforms using mainframes, and they have rules engines built within the mainframes. Now these are very, very, very deeply embedded. uh, I mean, to be very honest, re-architecting them to be an AI native and supporting them, for real-time AI decision making is very complex and very, firstly because they need to come out of their legacy environment, and that is a difficult challenge. What even in my personal experience we have faced, right? As that's the reason in the previous question I was talking about, right? The data migration that we are doing, right? If we want to use the AI in the data that we have, first we need to bring out from the AI from the legacy platforms. That is the reason we have started utilizing, migrating the data into, data lakes or snowflakes where we can use the AI models, and we can start using AI, leveraging AI. So legacy heavy ecosystems very difficult, but obviously organization wants to leverage AI, so they are doing it. Another thing is regulatory and compliance constraints that we have, for a lot of these, like especially from a healthcare perspective, right? A lot of uh, pulling out the data from the legacy environment, and also handling PHI information. A lot of data privacy is involved. Audits are there. So this also makes it a little difficult. We cannot just put everything in our AI models and ask them to train, because data privacy concerns are there. So I believe there are a few challenges, but yeah, organization are slowly moving and trying to adopt. And as I said, as Amit said, we're not rushing the transformation, but we are currently into the foundations. We are currently building the foundations and trying to see how much AI we can leverage.
Yeah, thank you, Vishi and Amit. Let's go with the next question. Obviously, we need to leave some time for Q&A, but let's see how much we can cover. So, how can organizations integrate AI into existing cloud native system without major disruptions? So, Abhik, I would like to go for this question.
Oh, sure, absolutely. Thank you. The biggest misconception I see right now across organizations is they're thinking that they have to rebuild everything from scratch to become AI native. But in reality, the most successful approach is incremental. You evolve, do not replace everything. So the first strategy is to introduce AI as your as additional capability. You don't rip apart your core systems. You just add AI alongside what you have already, exposed through APIs. This allows you to experiment and scale without disrupting the existing workloads. Secondly, leveraging your existing cloud native architecture is the key. If you already have microservices or APIs or data pipelines, you're already in a strong position. AI can plug into these layers, whether it is enhancing decision making or adding intelligence to the workflows or improving your user experience. AI can do all of it just by integrating into your existing infrastructure. Thirdly, I strongly recommend implementing a AI gateway layer early. And this is for the governance part. This becomes your control point for most access, security policies, and monitoring. It prevents what I call shadow AI, where teams start using models without governance, right? And that's where the major wastage happens, and then people go out of line there and everything. And so another critical aspect is to use the existing data platform. Don't create parallel ecosystems, which is hard to manage later. Extend your current data pipelines to support the AI use cases. Feature engineering, training the model, or data real-time interference, right? So from the operational standpoint, you need to extend DevOps into MLOps with integrated security controls, things like model validation, drift detection, and access control. And finally, start with the targeted use case, copilots, summarizations, anomaly detection, where the business value is clear, but risk is manageable. And then build and then scale it later, right? To summarize, the path to AI native is not the whole transformation. It's a layered evolution on the top of your cloud native foundation with cybersecurity and embedded at every step, like Amit said, right?
Yeah, that definitely, Avik, those are very excellent points, and I'd like to add a few more points to it. Like the safest way to add AI to existing cloud native platform is to make AI modular and adjacent, not invasive. So API first integration, microservice wrappers, event-driven triggers, and hybrid cloud edge patterns let teams introduce AI without rebuilding core system. A low disruption integration approach would be like use event-driven workflows, right? So that you are not tightly coupling and trigger AI actions from business events instead of putting AI into every synchronous request path. And second point, I will say roll out incrementally. Start with one workflow or department and measure impact and then expand. So that would be the right approach that implement,
Yep.
bring the outcome and then and measure it and expand it.
100% agree. Yes,
Yep.
yes.
So, yep. Avik, you wanna?
Yeah, sure. So, I mean, I think since we are discussing cybersecurity,
Mhm.
so I mean, I don't know. Do you want to answer like what new cybersecurity risks are introduced specifically by AI native systems?
So yeah, so AI native systems. That's a definitely good question. So AI native system introduce a new layer of cybersecurity risks, right? That go beyond your traditional application security. One of the biggest risk is data poisoning, obviously. So it's like the quality in, quality out. But when someone is providing the data, so based on the data you are providing to your model, and if it is being trained on the bad data, the bad outcome will be. Where attackers can obviously manipulate training data so the models learn incorrect or biased patterns, and this can slightly affect outcomes without triggering obvious system failures. Another growing concern is prompt injection, especially in generative AI systems. Attackers can craft inputs that manipulates the model into revealing sensitive information or producing the harmful outputs. Right. Uh, so there is also the risk of model leakage, where someone can extract confidential data from a model simply by interacting with it over time. And then what makes these risk more challenging is that AI systems don't always fail in a visible way, like the the reactive systems. Instead, of crashing, let's say if some microservice is crashing and not responding, instead they may produce output that look correct, and you may not notice it, but are actually misleading, right? And this makes detection much harder and increases the risk of unnoticed errors. So if anyone would like to add,
Yeah, good
uh,
point, Harvind. Very good point. So I just want to add a couple of points here. I think there are a couple of more things which we can consider is the AI supply chain, which includes the pre-trained models, dataset, or the third-party tools. That can also introduce hidden vulnerabilities if not properly validated. So those needs to be pre-validated before we can include them. Apart from that, security in AI native systems must go beyond infrastructure. It needs to cover data, models, and the entire life cycle with continuous monitoring, validation, as well as the strong governance so that we can ensure the trust and the reliability of the systems. Thank you.
yeah, very good point. Yeah, so we will go one or two more questions, and then we will open for Q&A. So how can cybersecurity be embedded into AI architectures from the beginning rather than added later? Navneet, would you like to take this question?
Yeah, definitely. That's a very interesting question and relevant. How can we the cybersecurity can be embedded into the AI architecture from the beginning rather than the added at the later? Because embedding cybersecurity into the AI architecture itself at the beginning stage is often called secure by design AI, and it is essential because AI system introduce unique risks that cannot be effectively mitigated later. The process start with AI-specific threat modeling, identifying risks such as data poisoning, model inversion, adversary inputs. Yeah, so those are the very valid points I can think about
Yeah,
at this point.
thank you, Navneet. So let's go with the next question. We need to quickly wrap up, Vishi. I will go with you for this question. So what truly defines an AI native system beyond traditional cloud native architectures? Vishi?
I am sorry, I was talking on mute. I'm sorry. I started answering. I mean, I started saying, but I was on mute. So I know we are running short of time, and we have time for Q&A. As I said, I was just saying, the AI native system, isn't just about cloud native with models layered on top. Uh, Basically, the AI system is a shift where the system that that execute logic to systems, basically the system that can learn and make decision continuously. you know uh, basically what we are trying to do is an AI. When we talk about AI, we always talk about data centric, right? So the shift that we are moving right now, from the traditional cloud native architecture, which is based on service centric or rule based centric, we are moving towards data centric, learning centric, learning, the learning driven, that's what we call it, in the AI world, towards that architecture, so, and again, security is very important. Here we also talk about, having a closed loop learning ecosystem also, you know as I said, I'll quickly close this answer. So basically, how what is happening right now is we're evolving from, as I was saying, the rule based to model driven, instead of static rules, which was the how what's the traditional cloud architecture was. Here the decisions are, dynamically generated using machine learnings and LLMs and AI models. These systems would operate in real time, often using, event driven architectures, doing, triggering intelligent actions, and, uh, how do I put in, probably, having intelligent action mechanism, you know and as I always say, from the healthcare perspective, uh, in the cloud native systems you might have, scalable AI processings, but in the AI platforms, scalability is there, but the platform will learn on historical data, historical claims, if I put from the healthcare perspective, or the provider behavior, or the patient platforms, to dynamically decide approvals, flag anomalies, or detect fraud in in real time. So what I would suggest, what I would say, for me, what AI native system is really is, it's just not designed to run the application at scale, and, we define the rules. Where what we want the AI native system is, to learn from the data that we have, learn from the healthcare data that we have, and make real time decisions, real time operational decisions, make real time clinical decisions, and continuously evolve, while remaining compliant,
Yeah.
and accurate,
Yeah.
because
Thank you. Thank
yeah.
you, Vishi.
Yeah.
Yeah. Thank
I
you.
try to I have a few more points also, but I try to wrap it up as soon as possible.
Yeah. Thank you. Thank you, all the panelists. But now, almost 9 minutes left. So let's open for Q&A, and the attendees are open to ask any questions. Please feel free to add or ask any questions to the
Yep, I
panelists.
already got a couple of questions in the chat and I reverted
Okay,
back again.
let's pick them up.
Yeah. If anyone have any other questions, yes, go ahead.
Yeah.
I think it's room now open
Yeah,
to
there are a
all.
lot of questions. So the first question, are we sharing any data? Yeah, the only the poster, because this was a panel discussion, so we just thought to share the poster. That's all. So we will see how many questions we can cover. We will go top to bottom. So Michael has asked this question: is there a standard definition of AI native beyond architectures that learn? If so, where do they exist? Not in cloud, but in
I
data
think
centers.
already answered. I think we have already answered this.
Already
Oh,
answered.
answered. Okay, good.
Yeah,
Yeah,
most of the questions are answered.
no
There's only one question at the end, I think. That's
Mhm.
the healthcare. So I think you can take that if you want.
In the healthcare, there is a move towards accountable care, which is the far more complicated than paying a claim, generating capitation. Can the data be aligned to make deterministic that health interventions are effective for the patient and
sure.
also allow payers to measure effectiveness of a. So anyone healthcare side, Amit
Yes,
or Vishi,
I
would you
will
like to
take
take this?
that.
Sure.
Yeah, Parveen, I will take. Yes, I said yes, but only if you treat data alignment, attribution, outcome measurement as first class design problems, right? So the hard part is not having data, it's making clinical claims and social data comparable, right? And timely enough to support designs, right? So the bottom line is yes, data can be aligned to show whatever interventions improve patient outcomes and whether an ACO is effective. But it required discipline, attribution, standardized data model, right? risk as adjustment, because we already said that whenever we involve with the PHI, there is a high risk, right? And that we need to take a more cautious. So paired quality cost measurement. AI can accelerate insight, but the credibility of ACO performance is still rests on solid data engineering and measurement. So I think
I just had a point. This is a real life use case that you're building on where the data is, very important. So, Brenda, in healthcare, duplicate processing is one of the most important functionality that we have, right? And that is not for the payer, but actually for the patient, right? So, we we get around, I would say, 3 to 4% of claims every day for duplicate processing, and we have manual rules engine. And even after that, we require a lot of manual intervention to process those duplicate claims. Now we are running the, we are trying to align the data, and we are running the data that we have right now for the duplicate claims, and trying to run different models, and trying to see if we can come up with some mechanism, to reduce the the manual intervention that we have. So yes, there are difficulties in data for training the, especially in the healthcare domain. But yes, there are small steps that we are taking, and the real life use case that I told, right? Duplicate claim processing to reduce the manual intervention. Because even after putting in a lot of rules engine, right, the rules engine that we have, the in legacy platform, still fails to, flag all the duplicate claims, and they still get flagged as suspected duplicate claims, and the adjusters comes and work on manually. So we are trying to do that, and utilizing the existing data which the claims which the manual basically the manual adjusters have worked on, and flagged them as, well, not just potential duplicate but real duplicate claims.
Yeah.
So we are doing it, but it's a very incremental approach, and we are taking it a very cautious approach to ensure that we are not flagging any not a duplicate claim as a duplicate claim. So
Yeah.
that concern is there.
Thanks, Vishi. So I'll take the next question from George. When having a system makes business decision, how is it held accountable for massive mistakes or physical accident made? Example is denying a claim or medical procedure, but can be expanded to anything else. So my point here is that the accountability still rests with the organization deploying the system. Means you are deploying the system, you are developing the system, you are accountable, not the AI itself, right? They are responsible through like human oversight, review, override decisions. Obviously, when you have to validate it, audit trails and explainability why the decision was made and how the decision was made, and then regulations and compliance. For example, healthcare laws, HIPAA, PHI, PII, those kind of information, and then liability framework like company, developers, or operators are legally accountable. So AI is a tool, right? This is not something you are using the AI and then say, hey, has been done by the AI. The legal and ethical responsibility stays with the human and institutions which are making use of AI. So that I would like to that.
Yeah, and absolutely, and I would like to add to it, Harvinder. First of all, whoever asked this question, it's a absolutely very great question. This is a great question actually, and sooner or later the whole world has to encounter this. But I agree to Harvinder, and I think just to add on that, the decision traceability need to be there. Meaning, although AI is doing something, first of all, human in the loop has to be there, but it has to be done through a policy. Meaning, even if it is denied, a claim is denied or something happened, which policy or which rule, which guideline triggered it, that has to be properly there. Means decision logs, what are the which version or which timestamp, which inputs, who approved it, what factors influence the decision. All those traceability and accountability has to be there, even if we are putting AI into to make the things faster, right?
Yeah.
I would like to add one more point here. So there are some insurance and risk transfer as well involved here, because some companies, normally people, organization, they can carry professional liability insurance, cyber AI risk policies, but this doesn't remove them from accountability, but it spreads the financial risk. So there is a uncomfortable reality. We know that there is a gap between technical causation and legal responsibility right now. So the system can behave in two ways, where no single human directly intended, but the law still forces accountability into whoever deployed it and sometimes whoever built and sold it.
Yeah. And then the next the question Nitesh like asked, everyone is racing towards AI native
Yeah,
cloud.
let me
What
take
was?
this, Praveen, if you want.
Sure. Yeah. 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 Go ahead.
So the thing is there, the modernization should not mean simply replacing any system like mainframe or any of the legacy systems, right? It should mean preserving their resilience principles while extending them into AI cloud and hybrid architecture. So if you see that all the 500 Fortune companies are still using mainframes in the back end, right? They are interest because they are built around disciplined reliability, transactions integrity, workload isolation, right? Predictable performance, strong recovery, security, and auditability, right? Many cloud native systems gain speed and flexibility, but sometimes lost that deep engineering disciplines, right? So you've seen that most of the time someone make a vulnerable any cloud system, right? Recently, one incident happened when someone hacked their key and they can utilize their models and they can present the means, and Google submit a bill of around I think 200 million to the customer, right? That he never used that. So that type of things happen when you have using a cloud or any AI systems, right? So that behavior you need to be controlled.
Yep.
Yeah, yeah, Amit. I want to add. Uh, Nitesh, first, great, as Amit pointed out, great question. Okay, and moving from mainframe is not easy. I know a lot of organizations have been trying to do it, but it's moving at a very slow pace. They really want to adopt AI. Okay, but can they replace the core functionality that is happening in mainframe, the bulk processing that they do in mainframe? It's a question mark there, to be very honest. Okay, I'm working in a system where we are trying to modernize mainframe into a more cloud native or AI native architectures, right? uh, but we are being very cautious. We are not trying to touch the core functionalities, which actually is the bread and butter of the organizations. We are trying to pick up small functions. Earlier in the question, I think everyone was asking, right, how do we see within 3 to 5 years, right? 3 to 5 years, they want. Right now we are trying to put small functions, as I think I was asking Brenda, right, that how we are taking data into consideration for duplicate processing. So that is one of the functions that we are trying to plug out of the legacy platform and trying to see if that AI can resolve it. But if you can talk about replacing the entire architectures and putting them out of in the AI native cloud architectures, certainly not in the near future. Yes, they want to go there, but they don't want to touch the core functions that they have. They want to first do the incremental functions, to try doing it small, resolving the functions, small business problems, like duplicate processing or the claim edits. So if that is successful, probably they incrementally touch the core business rules as well. So we'll see. But to be very honest, mainframe is not going away so soon. It's still there.
Yeah, that's a very good point, Vishy. And actually, the modernization isn't about replacing mainframes, but it's about carrying forward their resilience into AI native designs, right? So mainframes set the gold standard for fault tolerance, consistency, and uptime. And so AI native
Right.
cloud system can reach that bar, right? But only if they intentionally adopt similar principles like reducing redundancy, strong consistency where needed, graceful degradation, and the rigorous observability. So the real goal is hybrid resilience and combining cloud agility and AI intelligence with the discipline of mainframe reliability. Okay, so I think we are at time, but anyone has any last minute question, we would be happy to answer. I mean, feel free to speak up if you like. Okay, so I think thank you everyone for joining us tonight in this session, and really good discussion. Thank you everyone for your time, and
Thank you.
Yeah, thank you again. Thank you, Harvin, and thank you other panelists, and thank you, Harvin and Antra, for giving us this opportunity and scheduling this. Okay, thank you so much.
yeah, thank you. Have a good
Thank
Thank
you,
you.
Harvendra, thank you, Antara, and thank you everyone for having me here. Thank you.
Yeah,
Thank you.
thank you so much. Thank you all.
Thank you all. Bye-bye.